I'm making a video game with underwater mechanics. In this devlog, categorize player feedback, game systems, bug fixes, new enemies, new world. Thank you so much to those that tried my game and responded to the survey, sent Discord messages, responded on Reddit, or played on Twitch and offered their suggestions. The game will be much better thanks to all your input. Just like last time, I gathered all the feedback into a document and categorized it. From the list, here's the actionable items. Game difficulty, health and oxygen separation, frustrating mechanics, feature suggestions, bug fixes. While developing the game, I playtest levels a lot. Part of the feedback I got was that certain levels were pretty challenging and I may not notice since I have already mastered the mechanics. In order to address this, I plan to offer an option to set a difficulty. The game will be designed with the hard difficulty in mind, since it will be what I can realistically beat. Then things will scale down from there. Part of the feedback received included the frustration of being hit more than 3 times, trying to beat the last level, and then not having enough oxygen at the end. Currently, the player has to balance time and health, but the combination of both makes it hard to determine if they should restart the level because they no longer have enough time. In order to make that distinction clear, I decided to create a separate health system. For this new system, I wanted to make use of events to avoid making the UI element a dependency of the health system. I modeled my system similar to Game Dev Guide's custom event system. The game manager is responsible for initializing the health system with the amount of health desired. The amount of health is determined by the difficulty. I first got things working just printing to the console. To test my event setup, I added a text component that would display the current health value. I then added a UI component to display the current health. I had the idea to use a pie chart to emulate the health UI from Mario 64, which worked quite nicely, but it wasn't immediately obvious how much health you had. I then had a better idea to display the health. I made individual bars for each unit of health and changed the color of a bar when health decreases. I ended up using a horizontal group with some padding and making it control the child size and set child force expand. This made the bars scale nicely based on how many health units I wanted. I then created a prefab and made the health bar instantiate 1 bar for each unit of health. This looked pretty nice. In this clip, I'm setting the color of the image to the off color as soon as damage is taken. Since I wanted to show the bar depleting, I created another game object that had a background image with the off color and used a coroutine to lerp the values from 1 to 0 with the same duration as the player invincibility. As the last step, I tied the game end condition to an event fired when the health goes to 0. The first version of the oxygen system originally reduced amounts based on what a player was doing. The same system was updated to reduce oxygen on a regular interval. Since the player's actions have no impact on the oxygen levels anymore, this was a good time to decouple those from each other. Similar to the health system, I created a new component that was responsible for handling the oxygen value and would notify subscribers when the oxygen value changes. In order to test that this event was working, I set up a text element that would update based on the events that fired. The old UI read the value of the oxygen in an update method. The new UI only reacts to changes. Since I wanted the UI to be consistent, I created a horizontal group with a circle icon and a bar that would deplete just like the health system. I changed the color tone and added text with the same font as the timer. I then created a placeholder bubble icon for the UI instead of the circle. I asked my spouse for tips, and she suggested adding a little bit of a shine effect on the corner, which looked great. I then removed the old oxygen system and oxygen bar. Here's what the new HUD looks like. After adding the new systems, I reworked the coupling between the various components. Previously, the player would end the game when its oxygen depleted. With the new systems, the game manager tells the player when to die, and the health and oxygen system notify the game manager when their resource depletes. After updating the game manager to respond to the health system, I noticed that the amount of chances you have didn't really match the UI. With the new system, you can take 3 hits, but the third hit kills you, so realistically you only have 2 chances to get hit. I updated the health system to allow a player to live with 0 health. Then any damage after that ends up dealing the killing blow. Playtesters pointed out an annoyance with trying to grab an item that is on your head. Since the player now has a flat material, the item won't stick to the head and slips off. I updated the grab mechanic to allow you to also grab a chest above you if you're not currently holding an item. The item grab priority checks for items within the original circle range first, and then items on the player's head when determining which item to grab. A bug I never encountered was the oxygen depleting while you're in the score screen, which was caught during a playtest. Since I don't stop the oxygen from ticking, it is possible to run out of oxygen after completing a level. With the reworked oxygen system, I added control points so the game manager can decide when the oxygen should begin and stop depleting. Now, when the level completes, the oxygen correctly stops depleting. While watching a playtest, a user noticed that pressing the C key would freeze the game and a player would have to restart the level. This bug was caused by the removal of the fog of war but not unbinding the minimap key. So when the minimap tries to display, a null reference exception crashes the scene. I decided to bring the minimap back based on other feedback. Since the game is no longer about finding the chests but bringing them back quickly, the minimap helps a player determine where to go next. A player reported that sometimes they would load into the level when the timer was at 3 seconds. This is due to loading the scene and not waiting for the load operation to finish. I updated the scene loading mechanism to be async, similar to this sample from the Unity docs. Now the scene doesn't start the timer while it's loading the rest of the objects. I do want to add a little bubble animation or something as it loads in the future. On the last devlog, I mentioned wanting to introduce motion-based danger to the game, so I started working on a few mechanics for new enemies. My first idea for an enemy was to have an enemy that increases in size once hit, so I started by creating a rough version of a circle that expands. I added a collider and ability to do damage, just to see how it felt when trying to avoid it. Since I liked how this behaved, I decided the most appropriate fit for this would be a pufferfish. This new enemy would have 2 states, a regular sprite and a blown up sprite. I thought I could implement the behavior I wanted by having the sprite alternate and just increasing the collider scale. That didn't work, so then I tried swapping the sprites and having 2 sets of colliders which worked better. Content with having figured out this part, I moved on to the next enemy design. My next idea was to create an enemy that can pop from a wall and do damage, maybe some sort of eel. I feel like that's never been done before in an underwater game, so it might work. For the behavior, I wanted the body to pop out fast, but slowly pop back into the wall, then wait a period of time before repeating. In order to control the behavior, I made a simple state machine for the 4 states so I could play with the transition times. Happy with the way this worked, I decided I could iron out the transition behavior and try a coroutine when I got to the actual implementation. With the mechanics I was going for established, it was time to start on some art for the new enemies and new world. The new world will be based on corals. The first thing I established was which colors to use for the tiles. I started by creating a color ramp for the tile tones based on the sandy tiles to keep consistency. I then tried adding a 5-tone color ramp with purple and pink shades, and used the jumble feature in Sprite to see if that felt like corals. This did end up looking a lot like the sandy tiles, but I think that will be fine since I can have more props that are actual color shapes to make the area feel like a coral reef. Knowing that I used 26 and 45-degree angles in the sandy levels, I also created tiles for these diagonal ramps. I also created a single width horizontal and vertical set, since I used those in the sandy levels. To keep consistency, I took metrics for the sandy tiles physics shapes so the player would sync into the tiles at the same level. I then created the physics shapes in Unity, referencing the metrics for the previous tiles since some of the shapes were hard to get right. I spent a while drawing different shapes for the pufferfish until I was happy with the design. I did have 2 designs for the larger pufferfish I debated between. I started by drawing some basic shapes based on the shape of eels, starting with the body section. My plan is to make the eel longer by copying the body section since it should tile nicely. I got a second opinion and my spouse suggested I set the fin on the top instead of on the bottom. An additional tip she gave me was to alternate the body curvature so it looked less like an 8 shape. Since these enemies have different lengths, I played around with an idea of coloring the fins based on the length of the enemy so the player doesn't have to memorize the length based on precision. I wanted to have a world-appropriate static trap as well, just like in the first levels. Based on the theme, I decided on using an anemone as a reference. I drew a few different shapes and went with the option I thought looked the best out of all of them, though I'm still not in love with it. I also played around with various levels of outlining for the current anemone to see if I like those better in the future. I started by importing the pufferfish sprites and naming them appropriately. My first idea with the pufferfish behavior was to scale the initial sprite and then at a certain scale swap it for the updated sprite. This looked a bit jarring and I asked my spouse for an opinion. She suggested scaling the small one from 50 to 100 and scaling the big one up from 50 to 100 in an animation. I played a bit with the animation speeds and scaling times until I had something that looked okay. With the animation feeling good, I added the hit behavior for both parts of the pufferfish. On the code side, the pufferfish works by listening to an event that indicates when the small sprite is done expanding. The event receiver then disables the small game object, activates the large one, and scales it. The implementation of the moray is based off of the wall popper test I did, using a coroutine to handle the transitions. The game object is composed of a body object and a transform. The body is also a prefab and is responsible for the collider and dealing damage. Each of the states can have its own transition time, which will allow me to set up morays that both close a distance at the same time. Once that was working, I added it to a test scene to figure out how far the moray extends based on the target transform. I then tried a combination of both the pufferfish and moray just to get ideas for future levels. The levels for World 1 were created by copying an old scene and deleting values. For these new levels, I wanted to start fresh from a scene and go through my setup checklist. I had seen someone use a custom editor and try to make an editor that would run through my checklist and tell me what I'm missing. While implementing this, I wondered if Unity had some sort of template it could create out of scenes. Turns out it does, but it seems like maybe they don't work as well. Based on that info, I continued improving my scene checklist editor, initially only using debug errors to denote what was missing. Then I worked on adding toggles that report the state instead of just relying on debug errors. Then I kept on adding and updating components until all my checks passed. And for the final test, I added a floor, enemy, and checked that everything worked. I did give a shot to the Unity template, but that scene had some errors and it seemed to create copies of everything, similar to this post. After watching a GDC talk on designing Celeste, Matty Thorsten mentioned that the level design philosophy for Celeste was similar to arranging a song out of pieces. This gave me the idea to use the printed versions of the original levels and try to form phrases out of the obstacles. A phrase is a group of obstacles where a specific movement is required to get through them. I then used the number of phrases as a measure of challenge. Level 1 has 4 to 5 phrases. Level 4 has 6 to 7. Some of its phrases are longer, and you have to go through them twice. This felt like a good way to try to quantify challenge and increase it by slowly changing the baseline of phrases per world. With this plan in mind, I tackled the design for the first level and the second world. For this level, I wanted to keep the phrase count between 4 and 5, but have a slightly longer phrase near the chest. Since the name for this world is Coral Castles, I used some castle shapes for inspiration and made a rough sketch of the shape. Like the levels before it, I started with a blockout of the shape. I measured the distance with and without boost, adjusting the size based on if the level feels too small or too big. A deviation from the previous process, I added the enemy prefabs directly instead of using damage blocks. Since the prefabs have different behaviors and sizes, it made more sense to use the real thing than to create prefab blockout shapes for these. Happy with that, I then added the collidable tiles. While doing that, I discovered some corner cases that were missing from the tile set, which was expected since I ran into the same situation on the first world. Just like last time, I created tiles for these in Sprite based on the collider arrangement. Then I exported them and updated the tiles, replacing the areas where I left the non-matching ones. I then added the filler tiles and the water tone. Since the minimap is now part of the levels, I set up the render to texture camera to have a nice view of the level. Then I playtested a lot, trying to see how fast I could complete the level without hitting anything. Here's a high-level view of the first level for this world. And here's what I consider to be the phrases for this level, with the last phrase being longer. That's it for this devlog. My focus for the next part will be support difficulty settings on the Pause UI. I think I'll try to also redesign the UI to use a tab system similar to the system by Game Dev Guide's video. Implement the next levels into the game using the array. Until next time.